Good afternoon, everyone. I'd like to share some of our recent work about Velox reading column-encrypted Parquet files for column access control, column level access control. So this is an agenda. We will first talk about what's CRC and Apache Parquet format. Then I will talk about Parquet encryption decryption mechanism, and also Parquet decryption flow, and how to enable Parquet decryption in Velox. Because Apache Parquet file format is the main file format used in Uber, and we use Parquet's column encrypted column for access control, column access control. So why do we need Parquet column access control? Because it enhances data security. It protects sensitive data at the column level. Like some column, they may contain like sensitive data, like maybe user PI, like username, email, or address, and also some business confidential data. This data should be encrypted at rest, and also its access should be controlled. So only permitted users can access those columns. Parquet CRC can also help improve performance. Because when we reading a Parquet file, we only need to decrypt the columns that are encrypted. With other columns unencrypted, so to reduce overhead of encryption and decryption. So with Parquet CRC, it can promote compliance and trust. It helps align with industry standards and legal requirements like GDPR and HIPAA. And it also increases confidence among stakeholders and customers regarding data management practices. So yeah, let's take a look at what's like a Parquet file format. Parquet file format is a columnar storage file format. This feature makes it possible and easy for us to do column encryption and access control. So like this is an example of a Parquet file format. At the beginning of the file and at the end of the file, there are 4 bytes called magic number. You can use this magic number to check whether it's encrypted or unencrypted, and also combine with another field later I will show to check whether what encryption mode it is. So on the left side of this graph, when you write a bunch of rows into Parquet file, it divides rows into groups. And each group is called a row group here. Inside each row group, the value of same column will be stored together. I think that's why it's called columnar storage. Like here, like inside row group 0, it has column A and column B, and maybe some other columns. And for each column, it further divided into pages, like page 0, page 1. And each page contains a page header, which has the metadata of the page, and also a page body, that's the data itself. On the right side, from the bottom, besides the magic number, it has a footer length. It denotes like what size of the footer, so that initially when we write a Parquet file, we can first write all the footers into memory and deserialize it into a thrift data structure. So besides some global metadata, the footer mainly contains the metadata of this Parquet file. Besides some global metadata, it also has like row groups. This row group correspond to the row groups on the left side. So for each row group, it contains metadata for each column. So Parquet encryption has 2 modes, plain text footer mode and encrypted footer mode. For the plain text footer mode, it encrypts selective columns and some of the metadata. Like this metadata may contain some confidential information. For example, like a minimum value, maximum value, and so on. For the encrypted footer mode, in addition to what the first mode does, it also encrypts the footer as a whole. So this is a plain text footer mode. You can see in this example, column A should be encrypted, right? On the left side, its pages like page 0, page header, and page data are encrypted. On the right side, for the column A's metadata in row group 0, some metadata was encrypted using this column key. And also the encryption metadata is stored in this column crypto metadata. It may include like the encrypted key and also some other metadata about the encryption. This is the other mode. Like you can see, it has the whole footer is encrypted with a footer key. And how do we do CRC via packet encryption? Like when we write data to a packet file, right? Some columns they need to be encrypted, and different columns can be encrypted using different keys. And here's the keys we call it working keys. And after we use working keys to encrypt this data, the working keys themselves are also encrypted by calling key management server. In key management server, there are master keys. Those master keys are used to encrypt the working keys. The encrypted working keys will be attached into the packet footer along with the other column metadata. When we're reading a packet file, encrypted packet file, we will send a request to the KMS to decrypt the working key. We also send the users, like a query owner's information, so that the KMS can decide whether this user has permission to decrypt the key. So the CRC is controlled by the KMS. So this is a simple flow of the decryption. Like when we read a packet file, we first read its footer, the metadata. Then in the metadata, we get the crypto metadata, the encrypted working key, and maybe master key name and version, those kind of metadata. Then we call KMS to decrypt the encryption key. Then we get the original encryption key, use this encryption key to decrypt the data. So the main change is first in the packet reader. In the packet reader, we need to pass the crypto metadata together, the encrypted key, and then use it to call KMS to decrypt this key. And the other part is in the page reader. When we get the original encryption key, we can decrypt the data. We first decrypt page header, then decrypt the page data. This change, we just send a pull request. It's still in review. Like when in the future, once it's landed, if you also use the packet encryption and want to use this decryption flow, you need to first provide your own KMS client to talk to your KMS. So we also provide a reference implementation of the KMS client. You can extend it and implement the method. So maybe you will need to do some authentication when calling KMS. So we also provide some caching in this client, and so if some columns they share the same encryption key, so it can save you some requests to KMS. So after you implement the KMS client, you need to enable CRC in config. So by default, this CRC logic doesn't affect the existing code, your flow. Okay, in the future, we may also want to support encryption in packet writer, and also to support encryption for another encryption mode, encryption footer mode. Yeah, that's all. Thank you.
Hey, how do you take care of interoperability? These files, can they be used by any other products, even at least for the unencrypted columns?
Mm-hmm. Yeah, so in a packet file, you only selective column are encrypted. So if your query doesn't access the encrypted file columns, it doesn't affect it. For querying access encrypted encrypted columns, when you read the packet footer, you can check whether it has a crypto metadata. If it has a crypto metadata, it means it's encrypted, and you need to decrypt it. Yeah.
Thank you.
Yeah.
Did you implement this in Uber independently, or are you using the Arrow Parquet implementation?
For the encryption, the algorithm, that part we use Arrow.
Okay.
Yeah.
Is there anything that you implemented specific to Uber internally?
We removed the Uber specific logic,
Cool.
so this is should be general enough. Yeah.
Thanks.